You didn't even miss the homework questions. What the heck? I'm so discombobulated this morning. 23. Y'all said 23? No? I thought I did this one yesterday. I feel like I did.
I need 27, 35, 37, 39.
That's exactly what I need.
27 and 48.
So we don't need 23?
No, we do.
We do. All right, let's do it real quick. 1/2 x squared minus 1 to the negative 1/2. Don't forget to chain it. The 2's cancel. So the derivative here is x over the square root. And I'm going to do it this way so that you can see. Remember, I want to know where it equals 0. Two different scenarios here. This equals 0. Those are my stationary points. Where this equals 0, I don't know why I did that little arrow. Those are my non-stationary, but still critical. Both of these are critical, by the way. Critical stat, stationary. So I have x equals 0. And then where does this equal 0? Actually, I need it to be greater than. I need to think about the domain, right? Are y'all with me? Because it needs to be positive. Because it's, yeah. So if you think about this, where is x squared greater than 1? Whenever I take the square root, right, I end up with this plus or minus deal. So x has got to be greater than 1, but then whenever I take the negative, that same kind of property where you flip the inequality sign happens. Because you're squaring it, you have to kind of think about this. Because I'm squaring it, if it's going to be bigger than 1, any fraction, right, is still, it's not going to be bigger than 1. Because what's a half squared? A fourth, right? And that's not bigger than 1. So anything falling and anything negative just becomes positive because I'm squaring it. If you were to graph this, you would see, I think this is the one that does something like this. So there's your domain on that one. So as I'm testing my points, right, if I made this equal to 0, I would find that x is plus or minus 1. Yes? But I have to, the reason I do all this is, one, I need to see where I have graphed what my domain is and where it's undefined. So all these places are where my derivative is not defined, and I am testing positive and negative 1. Right? Are y'all with me? I don't need to test 0. Why do I not need to test 0? It's not in my domain. That's right. And really what I should be doing is the domain of this one, because that's my original function, and not the domain of the derivative, but it's the same. All right. If you plug that in, you get 0 for both of them. So they're both minimums. You have a minimum value of 0 that occurs at x equals negative 1 and x equals 1. It is an absolute minimum value, yes, because the function itself, that's the minimum value of the function. Yes, the absolute minimum value of the function. What else did y'all say? 27. I bet we're going to have to factor. All right, so let's do a derivative. Just calculate. 1/2 3 plus 2x minus x squared times 2 minus 2x. Oops, it's negative 1/2.
I was doing this wrong.
You haven't changed anything?
I'm not.
That's no bueno. You look pained about it. That's, yeah. So you just don't.
I mean, I didn't know.
I am going to, just because I can see this having a common 2 here, and this is a half, I'm going to go ahead and do that. To give me 1 minus x up top, and then on the bottom I've got the square root of 3 plus 2x minus x squared. Go look at there. I know this is a non-calculator, but let's graph that original and see what we're looking like. 2x. I think they get a little crazy sometimes with some of their non-calculator stuff. Yeah? These points, though, I need to figure out, and I'm guessing whenever I factor that quadratic, those are going to be the points that I get whenever I factor instead equal to 0. But let's look. Again, top to 0. I guess, first of all, what's the domain of this one? What's your original domain? Okay, so it's got to stay greater than or equal to 0 because it's a radical. So I'm going to factor this. I'll probably take out a negative and make it x squared minus 2x minus 3. Minus 3 plus 1. Yeah?
Yeah. So why are you doing that? That gives you the.
I can find the zeros like this. Zeros where it crosses, that would give me negative 1, 2, 3. So I need to see at those points. Do y'all remember in pre-cal when we had inequalities like this and we put the zeros on a number line like this, and it was almost like a sign analysis, right? Where we said, okay, if I plugged in, let's say negative 2, I'd have a negative times a negative times a negative, which would give me negative, right? So that's not part of my domain because I can't have a negative under the radical, so that's not part of my. And then if I come here and plug in maybe say a 0, I'd have a negative times a negative times a positive, which would give me positive. That is greater than 0, so this is part of my interval. And then if I come here, whoa, sorry, something bigger, I'd also get a negative number. And because I'm only looking for places where it's greater than or equal to 0, well, that would only be here in the middle, which means my domain runs from negative 1 to 3. I would say if you didn't have a calculator, that's the way you'd have to do it. But if you have your calculator, you can graph it and look. Yeah. Well, you wouldn't be in an inequality situation there if it wasn't a radical. That's the only reason we're in an inequality situation is because it's a radical. I can't go negative under the radical. Yeah, and you can still do it, but if you don't have a radical, if there was no radical here, my domain would be negative infinity to infinity. There's no restriction on that. Yeah. What were you asking? Yes, and I'm going to get to that. I will. So this point, so right now I was just looking at my domain because as I find these points, I want to make sure that the points that I find are actually in my domain, because if they're not, I just need to leave them out anyway. So here, when I set this to 0, I get x equals negative 1 divided by 1 would be positive 1, right? that does sit in my domain, so that is a point that I need to test to check, right? And I'm testing all these because will I have extreme values here? Can I use the extreme value theorem is what I'm going to. Why? It's the domain is restricted, I'm a closed interval, and it's continuous. So yes, I can use EVT here to say there's an absolute. What? That's okay. If it's a restricted closed interval, so you have some values that it says, okay, the function is only between these two values, and it's continuous. Those two things happen, then I have an absolute max and an absolute min. And so I can do that. So I'm going to test all my points here, okay? If what is negative infinity? So not based calculus wise. You wouldn't say, you would just say you have a minimum or a maximum. But as far as saying you have the absolutes, if we use that EVT, because we always want to justify why we say what we say, right? So by the extreme value theorem, I know if you're going to use that, it has to be, you can't be negative infinity to infinity. Does that make sense? You could say it's a maximum on this interval by the EVT, because you could set the interval yourself, but it need to be a closed interval. That didn't make any sense to you, I can tell. But you can have, if the ends go in opposite directions, you're never going to have an absolute, right?
But if they go
You could have an absolute. Yeah. Yeah. Right. Sometimes I go too deep into. All right, so here I know I've already set this equal to 0 and done it in the beginning, so I'm just going to say x equals -1 and x equals 3. And so here are my points that I'm going to test. Yes? When you plug this in for x equals 1, I get, I don't know. Y'all, no. Nothing, no, nothing. I'm just fixing to say something really stupid. I got 2, and I got 0, and I got 0. 29. Here's your max, by the way.
I don't understand the one. Are they absolute or relative? When you have to do the product rule or the
The function value, the absolute lowest value of the function is 0, but it just happens twice. You don't understand somebody was saying something that they don't understand when something. Is that you, Mac? Which one are you looking at? Y equals x over x squared plus 1. So same thing, right? Extreme values where they occur. Derivative. The thing with the you can do either one. You just have to remember. You did product rule. Okay, I would do product. Are you talking about you did this and you don't know how to solve it? Okay. Okay. All right. Derivative of the first times the second plus the first times derivative of the second, which will be -1 times x squared plus 1 to the -2. Chain it. So this is 1 over x squared plus 1 plus 2x squared, nope, minus. I would combine these into one fraction, with a common denominator. This part. Just because I know I need the top to go to 0 and the bottom to go to 0, so I need them to be in just one fraction instead of two different ones. So my LCD here, this has got 2x squared plus 1. This has just got 1, so I need to give this one another. If you did quotient rule here, you wouldn't be going through this step, but you'd have a lot more in your first bit of work. So this would be x squared plus 1 minus 2x squared over that LCD, which is just negative x squared plus 1. Now everybody to 0. So this to 0, that would give me my stationary points. This to 0 would give me my critical non-stationary points. That's never going to equal 0. Because in order for that to be 0, this would have to be negative 1. That's never going to be negative because I'm squaring it, so that's never going to work. So I'm just looking at these 2 points right now. This can't happen. All right, so I guess we test them. What was my original function here? X over x squared plus 1. What's my original domain? Do I have any restrictions on it? Remember, if I have fractions or radicals, fractions, the bottoms can't be 0. Radicals, I can't be negative under the radical. But on this one, there's no way that bottom's ever going to be 0. We just looked at that, right? So I'm going to say domain is all real numbers. Does your graph back that up? X squared plus 1. Oh, type it in right, Stacey. Yeah, this graph looks something like this. Funky little asymptote at 0. All right, let's see what happens. So it looks like 1 and negative 1 are where these little humps are happening, which makes sense. So we'll test them at x equals negative 1 and at x equals 1. Again, these are going to be relative because it's not a closed interval, right? Going on forever. Y equals negative 1 over negative 1 squared plus 1, which would be negative 1/2. And then at positive 1, y would be 1 over 2. Min. Done. Just the derivative. So I'm going to guess that their funkiness was because they're trying to get it into a fraction so they can look at their stationary versus non-stationary, since that's what they asked you for here. Oops, plus 2. So derivative. Do derivative of the first times the second plus the first times, at least I catch myself most of the time, first times derivative of the second, which is just 1. Again, this is going to be like a common denominator type situation. So up top, I got a 2 and an x plus 2. And on the bottom, I've got a 3 and an x to the 1/3, or a cubed root of x. Over here, I've just got x to the 2/3. So I'm going to give them both a 3x to the 1/3. Top and bottom. This one already has it. Which would be 2x plus 2. There's a 3 here. That's going to make that a 6. Nope, that's plus. Golly, Stacy. Let me just write it instead of trying to shortcut everything. 2/3 plus 1/3 is, which is 1. There's not a whole lot you can do with this. You can distribute and combine and clean it up just a little. Is that not what they got? 5x plus 4. Same thing there, yeah. You can write it either way. Yeah. You could. That'd probably been smarter. And a lot of times it is smarter to rework it in the front end instead of the back. 2/3 plus 1 would be 5/3. 2x to the 2/3. Then you can just use power rule. 2/3 plus 2/3, that would be 4/3 x to the negative 1/3. What? Oh. Ew. Oh, there you go. This one needs a cube root of x. Still got to get a common denominator. That's x to the 1/3. When you add those together, you get 5x plus 4 over 3 cube root of x. If you're looking for your critical points, yes, because you need to know where the top is 0 and the bottom is 0. Seems awkward. X times the square root of 4 minus x squared. Domain on this one, I'm going to go ahead and do domain before I start. 4 minus x squared's got to be greater than or equal to 0, right? Subtract, I got negative x squared's got to be greater than or equal to negative 4, so x squared's got to be less than or equal to positive 4. So here we go again. And if it's easier for you to think about it like this to determine where your intervals are happening, do it like this. If I put like negative 3 in here, am I going to get a value smaller than 4? Like negative 3 squared is 9. Is 9 less than 4? No. When I divide by this negative 1, it flips the sign. Well, I was kind of trying to get you to understand the plus or the minus thing, but I think this will be easier for you to see. No. Don't do it this way. It'll be, because this is the way I taught you in pre-cal, so we'll stick with the original way I taught you. If you plug in 0, is 0 smaller than 4? Yes. For this interval, if I plug in 3, again, I'm back in the same. So what's my domain on this one? Negative 2 to 2. Yes. Because a radical, can you take the square root of 0? Yes, you can take you can take the square root of 0. If it's in the bottom, you wouldn't want it to be 0 because the bottom can't be 0. So it depends on where your radical is. If you graph this, it's a funky little graph. It looks like this. So my domain holds true on that. Does that make sense? Do y'all remember doing it this way? I should have just jumped straight back into that way. My bad. All right, so I do that to make sure that any critical points I find do lie within my domain because I don't want to waste my time testing points that may not lie in the domain itself. All right, so derivative of the first is 1 times the second plus the first times derivative of the second. 1/2. 4 minus x squared. The negative 1/2. What? If you're doing x squared equals 4 plus or minus 2, You solve it like an equation first. You test the points in the intervals. I do have to chain this. Robert's trying his best to make me forget to chain, but I'm not going to forget. Did you get that? You understand what you're saying? Yeah. All right, so I got square root of 4 minus x squared. Minus the 2's cancel, the x's actually cancel. I end up with 1 over the square root of 4 minus x squared. These are fun because the common denominator here is square root of 4 minus x squared. That happens to be what's sitting in the top over here. What happens when you multiply these two together? So it's just 4 minus x squared minus 1 over square root of, which is, I know this is boring, I feel boredom.
Not that bad. Especially the homework.
Dude, I just did most of them with you.
Oh, that's my point. You didn't with me.
I know. Everybody to 0 if I take this to 0. X squared equals 3, so x is plus or minus square root of 3. Is that in my domain? Well, if you subtract 3 and then divide by -1. Why? Oh, that's supposed to be x squared. You're right. They don't cancel because that's not in the bottom. Jeez, Stacy. This is dumb. So I had the whole stinking time. Is that my domain? What's my domain? -2 to 2. So yes. I am. Oh, I'm not. It's been a crazy morning. All right, how about the bottom? This has got to be greater than 0. It is, or well, if it's equal to, actually, I don't need it to be great. I just need to know where it equals 0. I already know where it's greater than. I did that in the beginning, right? Those are my endpoints. Those are my domain endpoints, right? I'm a restricted domain. Do you agree or disagree? Agree. So I'm going to test all my points. I'm going to test -2, negative square root of 2, square root of 2, and 2. I hope this is the last one y'all need. No, it's okay. It's okay. I was so stoked for.
Yeah,
I think that these are harder than.
it's fine. You can do the one.
MVT is so much more important than EVT.
Well, I'm all for getting rid of this.
Which one did you say, Avery? If we spend another day on this, then you have more practice on this. If f is continuous decreasing, so I'm on a closed interval, I know that. I know it's continuous, so I already know that I'm using EVT. Critical point at 4, 2. Which of the following statements must be false? That's right, it is B. All right, so f of 10 is an absolute minimum. Well, you can't know that. You can't know, it's not necessarily one of the endpoints. So then it says f of 4 is neither a relative max or min. You can't determine that. So let's look at C and D, because C says that the derivative at 4 is 0, and D says that the derivative at 4 is less than 0. And it says a critical point at 4, 2. Which of the following must be false? So critical point. Right. Critical, does it say, let me read it again. Critical, yeah, because critical is not stationary. So critical just means that the derivative equals 0. So that can't work, so it has to be B. B. An even function with domain, all real numbers, has a local max at x equals A. Then f of negative A what did you put? It's got to be the same thing, and let me tell you why. What does it mean to be an even function? Think about it algebraically. Remember whenever we had those times where I said, justify algebraically that it's even or odd. And we said for evens versus odd. For even, if you plug a negative x in, you get the original function back out. But for odd, everything changes whenever. So remember, odd was everything opposite. So even means even though I plug in a negative a, I'm still going to get the same thing I get whenever I plug in a regular a. That's what it means to be even. If I'm a parabola or something like that and I plug in 1, I'm going to get the same thing as if I plugged in negative 1 because I'm symmetric about the y-axis, right? So if it's a minimum or whatever it was here, what did it say? A max. If this is a max, then this is a max also, and vice versa, because you get the same value. And we're talking about y values. What else? Here's because I just want to introduce this mean value theorem. And tomorrow we'll talk about antiderivatives. Antiderivatives. I'm gonna just introduce it. It's gonna be quick. I have a couple problems with it. This is the one that is the most tested, in my opinion, on FRQ, that whenever they ask for a justification, MVT is usually your justification. Sometimes it is extreme value, but most of the time it's mean value theorem. But it makes sense, and let me explain. Actually, let me give you a scenario first. You're driving down the road, and you're on I-20, and you start out at 50 miles an hour. Let me show you the theorem first, and then I'll. Because this is it's a word problem that we do in here, but I'd rather, let me just show you first. Here's the mean value theorem in a nutshell. Same stipulations, I should have given them to you first. If f of x is continuous on a closed interval, then somewhere on that interval, if you find the average rate of change of the endpoints, then the instantaneous rate of change is that value somewhere on that interval. In other words, the derivative at some point C is going to equal AROC is just slope, right? F of X has to be continuous. Oh, that should say on closed interval. Say again? You talking about the difference quotient? You talking about the alternate definition? It's very similar. But this is y1 minus y2 over x1 minus x2, or vice versa. Is all this is saying. Because if you're on this closed interval, if this is A, f of A, and this is B, f of B. I'm closed interval because I'm just between these 2 points, right? The average rate of change on the interval AB is going to be, subtract your y's. Remember, this is just calculus making it a funny way of looking whenever it's really just slope. This is the slope between these 2 points, yes? What that's saying is somewhere at least one time on this graph, the instantaneous rate of change, or the slope of the tan line, is going to be that value. And you can literally see that here somewhere on here, maybe there, and maybe even again here. But at least one place on here, the slope of the tan line is going to equal the average rate of change. Does that make sense? That is mean value theorem. AROC has to equal IROC somewhere. But it's got to be continuous closed. So let's do an example. I'm going to just do number 1 with you. Well, we'll do a harder one. We'll do number 6. Start out easy. We'll do number 1. Oh, I'm sorry. I guess I should also add in here. It kind of follows if you're finding a derivative, but I guess we need to add it. Continuous and differentiable. If it's not differentiable, this doesn't work, right? Because you can't take a derivative of something that's not differentiable. No corners, cusp, vertical tangents. If it's a piecewise, the derivative from the left is the same as the derivative from the right. I don't want to do number 1 because that's going to, yeah. Could I use mean value theorem here? It's not one. This is an easier example, and I'm going to move into them. Why? It's continuous, it's differentiable, and it's a closed interval. So yes, I can use mean value theorem here, right? Tell me one value using the mean. Let's see how they word it on homework. If it does, and it does, find each value of C in the interval AB that satisfies the mean value theorem. In other words, that satisfies this. I'm just plugging in. Take the average rate of change of the endpoints. So the slope of the endpoints. And then I know that somewhere in this interval, and I know that this is x squared, I happen to know what this looks like, from 0 to 2. This is the 0.24. This is the 0.00. Mean value theorem says that the AROC here is 2. Do you agree? AROC of the secant line, because that's what we call that line, right? A secant line because it goes through 2 points. The average rate of change, or the slope of the secant line, is 2. What MVT tells us is that somewhere between 0 and 2, there's a tan line that exists that has that exact same slope. So 2 would be your final answer. That's exactly right. So all I want you to do on these, and it's on page 217. That is exactly what it's doing. That's exactly, but you got to make sure. You got to make sure 3 things. You got to check for MVT. So to do that, I need to make sure, 1, it's continuous. 2, it's differentiable. 3, closed interval. If all those are true, then you're right, I just do AROC. But I got to check for all those things.
So how do you get to 0 on that line?
I went, so if my interval is from 0 to 2, f of x is x squared. Then you say, no, I can't use MVT, and you move on. So for instance, number 3. Number 3 is f of x equals x to the 1/3, and it says on the interval from -1 to 1. So I need to check all 3 of these things. Number 1, is it continuous? Yes, it's continuous, right? Is it differentiable on its whole domain here that's restricted? This is one of those special ones we talked about that's not differentiable. No, that's right. X equals 0 is a vertical tangent, so it's not differentiable at x equals 0. So I would say, no, MVT does not apply, and then go to the next one. Okay, so this is one of those special ones, those cubed roots that look like this, have a vertical tangent at 0. Now, if they had given me the domain 1 to 5, yeah, it would work then, because there's no vertical tangent between 1 and 5. The vertical tangent happens at 0.